we're going to do a video on scientific notation and division. And let's say I had $32 million and I decided to give it out to 2,000. I wanted to divide it into 2,000 allotments. And so if you want to do 32 million divided by 2,000, you'd say, well, it's going to go in where to, I mean, no. Well, 1, 2,000, and I get 1,200, and I bring down a 0, and then it's going to be 6. That gives me 12,000. There's a 0, and then you just, I mean, you're going to end up filling in a bunch of zeros. And so 32 million divided by 12,000 should be goodness me, this is a you know what? I actually did this wrong. Well, actually, this is a wonderful illustration as to why this is useful. I haven't done long division in a long time, so let's take a look at what I did. So 32 million. How many times 2,000 go into 3? 0. How many times 2,000 go into 32? 0. 0. Once. Now it's 2,000. And then I subtract, I get 12. And then I bring down my 0, and I can put in a 2. And so 32 million divided by 2,000 should equal 12,000. And like I said, I haven't done my long division in a long time, and it's not really a big deal because I know how to do this in scientific notation. 32 million, if I were to rewrite this, I'm going to try to pick a different color, and I'm going to say 3.2 times 10 to the 3, 6, 7. 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 divided by 2 times 10 to the 1, 2, 3 third equals, and take a look what our answer is. It was 1.6. Ah, goodness me. 1.6 times 10 to the 4th. Well, what I want you guys to realize is this. 3.2 divided by 2 is 1.6, and 10 to the 7th divided by 10 cubed actually equals 10 to the 4th. So my point is, if you're dividing, all you do is you divide the first numbers, which are your A values in scientific notation. You divide your A values, and then you subtract your exponents. So I'm going to give one more, well, that's not true. I'm going to give 2 more examples, and this looks like a pretty lovely color. So let's get rid of this one. I'm going to give you another example. What if you had something like this? 4.0 times 10 to the 12th divided by 2.0 times 10 to the 4th. Like I said, the first thing you do is you divide 4 by 2, and then you're going to subtract 10 to the 12th divided by 10 to the 4th. You subtract the exponents, you get 10 to the 8th. So it's going to be 2.0 times 10 to the 8th. There is one last thing I need to show you, though, and this is actually really, really important. I'm going to erase this up here. If you had, let's say, something like 1. I'm not going to do this to myself. I'm just going to make this easy. 1.0 divided by 4. Goodness me. I'm trying to rush. 1.0 times 10 to the 3rd divided by 4.0 times 10 squared. Well, the problem is 1 divided by 4 is 0.25, and then 3 minus 2 is 1, 10 to the 1. this is no good because here I said that A has to be between 1 and 10, and 0.25 is not. So what I'm going to do is I'm going to move my decimal one spot over to the right. I get 2.5 times 10, and now because I'm moving my decimal to the right, I actually have to subtract an exponent. It becomes 10 to the 0. If you're lost on that, I'm going to show you one more example, and hopefully this will help. Say I had 1 million divided by 50 million. Well, 1 million divided by 50 million. Once again, it's actually kind of a pain in the neck to figure this all out. I get 1 divided, which is going to be equal to 0.02. Alright, so I'm going to erase this. So 1 million is really 1 times 10 to the 6 divided by 5 point, well, 1.0. 5.0 times 10 to the 3, 6, 7. And so I get 1 divided by 5 is 0.2 times 10 to 6 minus 7 is negative 1. But since I have to move my decimal over 1, it's going to become 2.0 times 10 to the negative 2. And that makes sense because here's my actual answer, which is 2.0 times 10 to the negative 2 is 0.12, negative 1, negative 2. So they are equivalent. That is a difficult concept. I wish you luck, and that's it. Basically, divide these numbers first, subtract, and adjust accordingly. Alright, good luck. You might need to watch this video more than once.